Okay, the last lesson in this unit, just again, we're working with some sinusoidal problems here. We want to problem solve, we want to figure things out, whether they're comparisons or equations or parts of the graph or things like that. Okay, so we have two students riding their bikes, a pebble stuck in the tire of each bike. The two graphs show the heights of the pebbles above the ground in terms of time. As we've said in the past, anything with a circle over time is going to make a periodic curve. Okay, so I want to compare these two things. So we have bike A and bike B. So I'm going to make a little table. I think it's a good way of comparing things. Okay. So call this bike A, and this one will be bike B. And the first thing we want to do is compare our starting position. Starting. Okay, the next thing they want us to compare was, or be here, the radius. The tire is the same size. Then they want us to compare the axis, or axle, if you will. Okay, and then the period, and then the speed finally. Let's make this table a little bigger here. Okay, period and speed. And that would be a new one for us. We haven't done anything with speed yet. Okay, so let's take a look at bike A. Bike A would be, which one here? Bike A is the bigger one, the black one, if you will. Okay, bike A. What do we know about bike A? What's the starting position? Well, bike A, it looks like it starts at the top of the wheel. It's 60 centimeters above the ground. Okay, so that's the top of the wheel. Okay, the radius of that thing, how do I find my radius? Well, we've said radius, thinking about a wheel, is another word for amplitude, the difference between your max and your min, right? Or your central average and your max, or your central axis and your min. And so if I can find the amplitude, in our case, 60 minus 0 over 2, I can say the radius would be 30 centimeters. Okay, where's the axis of this? Well, axis and axle, interchangeable there, would be at 30. Because the axis for axis, we're going to make this into an equation. Y equals 30. Okay, it'd be where the center of that wheel, right here, right? Where the center of that wheel is. The period. How long does it take this wheel to go around once? Looking at that, it goes down, back up again, to about here. How are we breaking this up? This looks like decimals, right? 0.2, 0.4, 0.6, 0.81. Okay, so about 0.6 seconds. And speed. How do I find the speed of something? Well, that's something new. Something we should know about speed. Think about your car, right? Kilometers per hour. It's your distance that you travel divided by the time it takes to travel that place. In our case, we're talking about periodic things. The distance you travel is the distance around the circle. In other words, your circumference, 2 pi r. And the time it takes to do that, we call that our period. Now the good thing is, previously we had to figure out the radius. The radius we found was centimeters, 30 of them. So we get 2 times pi times 30 divided by the period we said was 0.6 seconds, I believe. Just go up here for a second. If I punch down my calculator, I end up with a speed of 314.16 centimeters per second. And I've taken something going around in a circle. I've turned that into a speed. And there we go. Hey, you guys try tire or bike B if you would. Okay, so if you have the same properties. Where's bike B starting? Yeah, it's starting at the bottom. I know that because my graph is down here at the minimum burst. My radius, my max, my amplitude. Max minus min divided by 2. Oh, it's 25 this time. That's a smaller wheel. Okay, my central axis is 50 plus 0 divided by 2. So y is 25. So my axle is mounted a little bit lower, which makes sense. Smaller wheel, smaller axle, or lower position for it. The period for that one, how long does it take? Looks like it's a little bit shorter, right about there, right? Halfway between 0.4 and 0.6. So this one maybe take 0.5 seconds. Oh, we got speed again. So what's the difference this time? Well, it was 2 pi r but radius was 0.5 this time. And the period, oh sorry, not point, wrong spot for that one. The radius was 25, the period was the 0.5 part. Okay, this is our speed. If I punch that one in my calculator, what do I get this time? Well, something kind of interesting. I get the exact same speed. So these are two different people riding different bikes. They're going for a ride together because they're going the same speed. And we problem solve some stuff. Something new. Distance, speed, and time. Okay, take a look at the second one. Give it a try. Got to draw ourselves a little picture here and see if we can problem solve a little bit. A carnival Ferris wheel, radius of 7. Okay, so we'll just think about that for a second. It's a wheel. My radius is 7. Okay. It makes one complete revolution every 16 seconds. And the bottom of the wheel is 1.5 meters above the ground. So if this is our ground, we know this is 1.5 meters. Okay, what do they want us to do? Draw a graph to show how rider's changes over time for 3 revolutions. Okay, I can do that. Okay, make the graph. 3 revolutions. We know 1 revolution is 16 seconds. So 1, 2, we double that, we get 32. And 3, we get 48. And there's our time. Okay, what's happening? They get on the wheel, and they get on the wheel at 1.5, right? It's above the ground. And how tall is that wheel? Well, that's 7. And that's 7, which makes a total of, how high above the ground? 7 plus 7 plus 1.5, 15.5. Okay, so I know I have to go up to 15.5, and this is my height. Okay, let's assume for simplicity, they're getting on the wheel to start. Okay, after 16 seconds, we'll be back to the bottom. 16 more, back to the bottom, and so on. We know the halfway point, so at 8, they'd be at the maximum, right? And again at 24, and again at 40. So we know our graphs can go up and down, and up, and down, and up, and down. And there we got ourselves a nice graph. Hey, part B. Find an equation for this graph. Well, this is what we were doing yesterday. Okay, what do we need? 4 important things for a graph. We need an amplitude, A. Now, I could do max minus min and divide that by 2, but I also know that my radius is my amplitude, right? That's why I got 7 there, because my radius and amplitude are the same things, like we did at the wheel a second ago. My central axis, I know if I add max and min and divide it by 2, I'll get 17 over 2, or 8.5. I know it takes 16 seconds for the period. So if I want to take 16, sorry, I have to down the wrong way there. 16 seconds is the period. Then I can get k by doing 360 divided by 16, and that works out to 22.5. Okay, and then I can build myself an equation. What do I got? Y equals A, our amplitude. And we said a second ago that was a radius. Cos 22.5. Is there a phase shift? Supposed to start on the maximum. Oh, that's moved. It's over here. How far is that? That's 8 units to the right. So minus 8 plus our C, our central axis, 8.5. There's our equation. I think there's a C part to this one. Predict how the graph and equation will change if the Ferris wheel turns more slowly. Okay, so what will we talk about here? Words now. The graph's going slower. The wheel's going slower. What's going to happen to my graph? Well, it's not going to change the height of it. The wheel hasn't changed in size. It's not going to be mounted in a different place. The axis hasn't changed in size. But as it goes slower, it takes longer to complete a period. So the graph would get stretched horizontally. If I start stretching things horizontally, okay, this will change two things actually. It'll change the period. So in the equation, that would be your k value. And because being stretched, the points are going to move slightly to the left and right. So it's going to change our phase shift, which would be the d. Okay, if it went faster, it would be compressed. If it went slower, it got stretched. Okay, that takes us to the first two there. If you want to flip over and try the back two, that would be a good time to do that.